So moving on then just to the demonstration, if I can try and share my screen with everybody. Hopefully now people can see my screen.
Yes, we can see M51 there on a PixInsight.
That's great. Thank you. So let me just start with practicalities, because I think it would be useful for people to be able to see how to get hold of this script in the first place. And the easiest way to do that is to go to Resources, Updates, Manage Repositories, and you'll see in there the list of the standard PixInsight repositories. You may have already added some others of your own, but the one that you want to add is this https //www.ghsastro.co.uk/updates. The add button here, put that URL in there, click the OK button, and then that will add that to your repositories list. And then you need to go again to Resources, Updates, and then click this Check for Updates. And that will then go away and check to see whether or not there is an update for you. And there isn't for me, of course, because I've updated it already. But this should then come up with a message to say that there is an update waiting for you. And then you just click OK to install that, and you'll need to exit PixInsight and come back in again in the normal way that you would load any new PixInsight update. And that will get you under Script, Utilities, and then down here, Generalized Hyperbolic Stretch. And this is the interface that you will be presented with. I will demonstrate some of the principles that Dave has just been talking about, and in a practical sense through the script, using the image that you just saw of M51, which is not one of my own. That is actually one of Dave's pictures, so thanks very much to him for sharing that. The first thing you need to do is here in this panel here, you need to load the image that you want to work on here. It's M51. It actually has a screen transfer function applied to it at the moment. You'll be asked if you want to keep that or not. I'll keep it. It doesn't really make a difference which way you go. Whichever way you go, the preview that you will get within GHS will not have the screen transfer function applied. So I've now loaded that image. The areas of the script to focus on, up here we've got the histogram jammed right over onto the left-hand side because it's a linear image. We've got the stretch transformation. Down here we've got the transformation parameters. And then over here on the right-hand side, we have got the image preview, which again is not very interesting because it's a linear image, so it's just dark. Now, what I can do is, and what I tend to do is really just, first off, move the stretch factor across until such time as I can actually see what it is I'm working with. So there is the image of M51. It's a stretch, but obviously a very bad one. We've got a huge burnout in the center of the galaxy there. We can do an awful lot better than that. Now let me just, this button here will zoom the histogram right in. So this is the predicted histogram of once we've applied the stretch. But what I really want to do is I want to look at this data down here, which is the unstretched data. And I can zoom right in to see all of that by that zoom button. Now, broadly speaking, the sort of area from the far left-hand side through somewhere into the histogram is background. Over here, we have got interesting data. This is data which corresponds to the actual galaxy itself. And somewhere between those two, there is a crossover point, which is not well defined, but broadly there's going to be a crossover point as we start to move away from predominantly background into predominantly interesting data that we want to reveal. And that's the point that we want to put the SP point. Now, because this is an image where most of the image is actually background, we just got a smaller amount, which is subject matter. I would expect that that point is going to be to the right of the histogram peak. That is to say, the majority of these histogram pixel counts are corresponding to background. But the way to find that, we've implemented this readout control, so I can click anywhere on the preview, and that will give me a readout reticle. The average pixel value within the square of that reticle is given up here, and it also echoes that average value where that appears on the histogram. So I just click and drag, I can zoom into the preview, and I can move that square around and get a feel for at what value do we start to move from sort of background, which I guess is down here, up into something which is corresponds to data that we really want to reveal. And that is showing a value around about 0.0009. It's this gold line on the histogram. That's probably the number that would make a good starting point for my symmetry point. So I can either type in the 0.0009 down into this box down here, or more conveniently, I've got a little button up here which allows me just to send that value immediately down to the symmetry point. So if I now reset that zoom, and I can reset the zoom on the histogram, that's set my symmetry point. Now what I want to do, actually, sorry, let me just go back in here. You'll see that what that's done to the transformation graph is we have now got the maximum contrast. There's a bit of an inflection point going on in there, but it's not much of an inflection point. What we really want to do is to pull in a much stronger contrast in at that point. And typically you're probably going to be looking at something in the sort of 8, 9, 10, maybe even slightly higher level for that stretch intensity. And that will then get you to an image which looks something like this. And of course the galactic center is now really nicely preserved. The stars are nicely preserved. This is looking much more the sort of situation that we want for our first stretch. So if I just come straight out from that, so that's probably as good as anything for a first stretch. Now what I don't like about this, probably two key things. Firstly, it's pretty monochromatic across the entire image. And secondly, it's pretty flat. The second of those issues I'm going to address with my second stretch. But the first of those issues is something which I can address right now with this initial stretch. It's a feature of really all hard initial stretches. You get it with histogram transformation as well. That initial stretch tends to bleed color out of your basic data. There is a process within PixInsight, the arcshine process, which a lot of users tend to use because it tends to preserve color. And it's not actually the arcshine equations that are preserving the color, it's the way that those equations are being used within the stretch that's preserving the color. So what we've done here is we've allowed that same process of using the equations in what we call the color stretch over here, but we're still using the generalized hyperbolic stretch equations. If I click on the color option, you'll immediately see that color sort of almost magically jumps into the image. As I say, it is because of the process that's being used to apply that stretch. So that's probably quite a nice first stretch that does what I want in terms of preserving color and also preserving the stars and the galactic core. So I can apply that by clicking the green tick down here. What I'll actually do is I will create a new image rather than overwriting the data on the existing image. And there we go. By default, the script will choose the new image that you just created and make that your new target view. So now what's happening is it's reapplying a further stretch on top of that. So if I just use this little button down here, I can reset the parameters and get back to where I was expecting to be. Turning to the log view that Dave was talking about earlier, this is looking from the streets of the city up at the buildings. We can still see that actually we're keeping things quite nicely controlled up here where the stars are. We're not blowing things out too badly at all. It's not a bad sort of downward stretch. There's a little bit of a hump going on here, but overall it's not too bad. But the thing that we don't like about this stretch is that there's really very little contrast across the image that is of importance to us. So the way to do that, again, we want to try and find a symmetry point. So let me zoom in on the image. And again, I can just click on the image. I can move my reticle around just to get a feel for what the values are out in these sort of spiral rings, which is where I want to add the next bit of contrast. And maybe something like this, somewhere in the sort of 0.418. It goes down as far as these 0.35s and up into the sort of 0.5s almost. But something like that is probably not a bad symmetry point to go for. Interestingly, that just happens to correspond with this hump, which is something that we want to try and stretch out, and that's no coincidence. That's really, this is the histogram demonstration of the lack of contrast at that point. So let me send that value to the transformation symmetry point. I'm going to reset the zoom. I want to, rather than the very intense stretch that I had for that initial stretch, I want this one to sort of spread out around that area. So maybe a value around about the sort of 3 level. And then start adding that stretch factor in. And very quickly we can see that actually the contrast is now coming right into that galaxy. So maybe something in that sort of, always tends to be a little bit of a dance between the various parameters, but maybe something along these lines gives us the stretch that we're looking for. It's also flattening out quite nicely that lump that we had on the histogram. This is now giving us the nice sort of downward trend within that, within the transformed histogram. One of the things that it is doing is throwing the background quite dark now. You'll see that actually that histogram peak is now being pushed to the left. So there's another parameter that we can use, which we call the shadow protection point. What that does is, to the left of the shadow protection point, we will make this transformation just a linear transformation. So if I start pulling that into the situation, you can see that actually we can get to a situation where we've actually got the identity transformation down here. So we're not really changing the background at all, but we are still creating that extra contrast around the galactic arms. So maybe something along those lines would do us fine. And what tends, I can apply that. The way that this tends to work is a bit of a dance, really. You do reset that. So you do your initial stretch. It's going to be pretty flat. You look at where you want to try to get the next bit of contrast. Do a stretch to try to get that contrast in, and then work your way around the image, adding contrast in the areas that you want. So typically there'll be 3 or 4 more stretches that you might want to do on this to try and get to your final position. But the basic principles are always going to be similar to the ones that I've just talked about. So I won't go any further on any of that. Just before I leave the script, just to point out a few extra things. There are quite a few different transformation types available. The histogram and arc shine stretch are both there, but then they are basically the same as within the sort of PixInsight processes of the same name, except that we've added this sort of additional functionality of symmetry points and shadow and highlight protections. You've got a straight linear stretch, which can be useful, but of course with a linear stretch you are always in danger of destroying data. Image inversion is fairly obvious. Image blend is not so obvious. Why would we put an image blend transformation type in here? The motivation for this was actually, whereas on this particular image the color stretch did quite a nice job and got color in quite well into the galaxy, sometimes what you'll find is that actually the RGBK stretch leaves you with a bit of a washed out look, but the color stretch leaves you with an almost cartoon-like look with far too much color in there. What the image blend transformation type will do is allow you to actually blend a little bit of one into the other. And the blending percentage allows you to sort of dance between the amounts of each that you blend together. And that can give you quite a nice sort of midpoint stretch. There are various other different stretch types up here. So you've got, you can stretch just a single channel, red, green, or blue. You can stretch just the luminance channel. And you've also got the ability to stretch the saturation. So that would allow you just to sort of pull a little bit of extra saturation into your image if that's what you wish to do. Down here we've got a number of different sort of option buttons. There's a link straight out to a dedicated website, which is quite useful because we've got on there a number of tutorials. Hopefully this will also be linked in due course. We've got links out to various forums where there's some interesting discussions which can be quite helpful to further share experience. I sort of feel like the GHS script is a little bit like a child. I sort of brought it into Dave and I brought it into the world, and we gave it life. But it's now out there and it's making its own friends, and it's doing things which we never thought of, and constantly surprising us. So really seeing the experience of experienced imagers and how they're using it has been very, very rewarding. There is a comprehensive documentation available on within the script. worth knowing about the preferences dialog, where you can change the look and feel of the script and also how it behaves. You can change the size of the preview. So that's a dialog worth knowing about and investigating. And all of the stretches that you undertake are recorded in a log, which you can save out to a text file so that you know exactly what you've done if you wish to do that. This little button down here will just turn off the preview, which allows you just to see what's underneath, which can be handy from time to time. And then this X will get you out of the script. I won't save my log.